Hello, Algebra 2. This will be the sequel to the previous video that we have made yesterday. Like I mentioned to you before earlier, because we talked about what we call the arithmetic sequence yesterday, for today what we're going to do is we're going to be exploring the concepts of geometric sequence and how it's different. Normally these two kind of go hand in hand together because they're so related to each other. For today, I'm going to ask you guys some questions about the difference between arithmetic and geometric sequence in your homework and how to determine whether you guys will have a arithmetic or geometric sequence. And for today, you guys will be finding something called not a common difference. Like yesterday, we talked about how common difference is a huge part of the algebra 2, and in terms of finding the the arithmetic sequence, terms. But for today, the geometric sequence, we're talking about what we call a common ratio. The main difference between the two, or the main difference in arithmetic and geometric, basically is that arithmetic yesterday, as we have probably seen from before, we consistently add something. So in the notes that here that we have dealt with yesterday, we talked about how we consistently add the 3 to get to the next sequence. But for geometry sequence that we're going to be talking about, the major difference is that you're going to be consistently being multiplied by what we call a common ratio. So this is what's called a common ratio. Okay, so another type of sequence is geometric sequence. It is determined by multiplying a non-zero constant to the previous term. So then how would you be able to solve for these common ratios? Is that just like yesterday when we were talking about common differences, when you take a look at the second term and the first term, for example, and you just have to simply subtract them? Well, common ratio here is that you take these second one to the first one, and then you would just simply have to divide them. So if you were subtracting them yesterday, you would divide them today to find out the common ratio. So you take the 1 over 4, divide by 1 over 16, keep, change, flip, and you will get 4, and that's your common ratio, and you will get the same thing as demonstrated here. Okay, so let's go over some of these problems then. Determine whether each sequence is geometric or not. So like before, what we're going to do is we're going to take the second term, 6, and we're going to divide that by the first term, which is negative 2. Now, if you do 6 divided by negative 2, what we would get is a negative 3. That means that every single time what we're going to do is, can I multiply by this common ratio, negative 3, and get to the next term? Negative 2, 6, negative 18, 54. Multiply by negative 3. Negative times negative gives you a positive 6, right? So that checks. Negative 3, 6 times negative 3 gives you negative 18. Again, multiply by negative 3, you get a positive 54. So yes, this is certainly a geometric sequence. Next, 8, 16, 24, 32. Well, I take the second term 16 divided by the first term 8 and I get a 2. So is my common ratio 2 for this? 8 times 2 is certainly 16. But 16 times 2, it should be 32. It does not turn out to be 24. So the next number on the list, unfortunately, it does not match the common ratio from the previous. So then the common ratio is inconsistent. So therefore, what we have simply is that this is no, it's not a geometric sequence whatsoever. Okay? All right, so guided practice here. Determine whether each sequence is geometric. I would like you to try these two questions on your own. And please pause the video now and see for yourself if you actually do indeed get a geometric sequence or not. Okay, so first of all, the number one step is to always look for our common ratio and make sure that it's consistent throughout these questions. So common ratio here is 2 divided by negative 8 gives you negative 1 over 4 or negative 0.25. That's the factor that you're going to consistently multiply by. So if you take your calculator, if you would like to, take negative 8 multiply by negative 1 over 4 and get 2. Take 2 multiplied by negative 1 over 4, you should get negative 0.5. 2 times negative 1 over 4 should be negative 0.5. And negative 0.5 times negative 1 over 4, I believe, should get you 0.125. So everything checks out. So yes, this is certainly a geometric sequence. Next one on the list, I'm going to do 3 divided by 1, which gives me a 3. So that means my common multiple, my common ratio is a 3. 1, 3, 7, 15. Can I get the next numbers by multiplying by 3? I hope that you guys can clearly see that the answer is no, because multiply by 3 here is a 3, but the next one number should be 9 and then 27 if it's going to be that common ratio. So that should be your answer. Okay, so for these two questions, I would like you to take a look at determine whether each sequence is arithmetic, geometric, or neither. Now, because we have explored the different concepts of arithmetic and geometric, what I would like you to do is I would like you to set up any reasonings whether it's going to be arithmetic, geometric, or neither. So let me share with you guys how to do part A, and I would like you guys to work on part B. So part A seems like I can do either one or two things. Number one, I could check for whether it's arithmetic, or number two, I could check for whether it's geometric. First, let's check whether it's arithmetic. I take the common difference is the second term minus the first term, and it becomes positive 8. Now that means that if I consistently add positive 8 to this, that I should get the next number, right? So I add the 8, I add the 8, and I add the 8. So 16 plus 8 is 24, plus 8 should be 32, plus 8 should be 40. That should be the arithmetic with this common difference. So therefore, we know for a fact that it's not going to be arithmetic sequence whatsoever. Next, geometric. Well, we have 16, 24, 36, and 54. So what is my common ratio? That is what I need to solve for. Well, second term divided by the first term. Well, I know it's going to be a little bit of an awkward number, but you should get 24 over 16. You would reduce that to 3 over 2, which is the same thing as saying 1.5. So does that mean that if I consistently multiply by 1.5, do I get the next number? Okay, well 16 times 1.5 should give you 24. 24 times 1.5, if you type that in your calculator, you do end up with a 36. Times 1.5 again, and you should get a 54. So yes, this is a geometric sequence because the common ratio is consistent. All right, next question. I would like you to try this question on your own. Pause the video right now and then play it again once you're ready. Okay? All right, so as again, I'm going to check for two things. Number one, arithmetic. Number two, whether it's geometric. This is how you would show your work as well. Now for arithmetic, I'm always looking for my common difference, and my geometric, I'm always looking for what we call a common ratio. Arithmetic, second term minus the first term should give me a 3. So if I consistently add 3, I should get this. So therefore, it's not going to be arithmetic because it's not consistent with the list of numbers that's provided. Common ratio is 4 divided by 1, which means I'm multiplying by 4 every single time. 1 times 4 is 4, times 4 is 16, 64, and continues on. So you can clearly see how this one also does not match with this, so they are neither. Because it's neither arithmetic nor geometric for this type of question. Okay? Alright, so for these questions here, I would like you to try determine whether each sequence is arithmetic, geometric, or neither. I will give you these questions for homework questions to do. Actually, we did these two questions before here. So these three questions, I would like you to try them on your own. Make sure you check arithmetic versus geometric and find out what we call a common ratio or common difference. Common difference, common ratio, common difference, common ratio, and then prove how it's going to be arithmetic, geometric, or neither for all of these questions here. Next, because we talked about whether the sequence is geometric or not, what I would like you to do is I would like you to find out whether these guys are going to be geometric sequences or not. I'm going to help you with just number 10 here, and I'm also going to help you guys out with 6A. So you guys will be doing 6B, 6C, and these three problems, 11, 12, 13, 5 questions for today. Now for 6A here, I have 5 over 3, 2, 7 over 3, and 8 over 3. Now is this going to be arithmetic sequence or not? Well, there's only two ways to figure out, right? Arithmetic versus geometric. Common difference here is that it's 2 minus 5 over 3 because the second term minus the first term. I cannot subtract an integer number with a fraction, so I need to convert this into a fraction, 6 over 3, by having what we call a common denominator, as we have went over in the past. Minus 5 over 3 becomes 1 over 3. That's my common difference. So if I keep on adding 1 over 3 consistently Do I get the numbers in the list? Well, let's check. 5 over 3 added 1 over 3 is 6 over 3. Then it's 7 over 3. Then it's 8 over 3. And 6 over 3 is 2. And look at that. It actually turns out to be the same numbers consistently when I do the math. So that is definitely arithmetic. I don't have to bother checking for geometric whatsoever. So I just say this is arithmetic sequence. Okay, why bother doing the word for geometric when I already found out it was arithmetic, right? So you don't have to, spend time doing that. Next question here is determine whether each sequence is geometric. Again, to figure that out, you have to take the second term, negative 5, divided by negative 8, which is the first term, gives me 5 over 8. Now, if I consistently multiply that, do I get these other two numbers? Well, negative 8 times 5 over 8 does give me negative 5, but this times 5 over 8 gives me negative 25 over 8. So you can clearly see that there's that little inconsistency there. So it's going to be no. I was about to write neither, but that's not the question that's asking. You just simply have to write no. But if you just write this for your answer, obviously I'm not going to accept it. Please write down the work for it to prove it. Okay? All right, so that's it for today. Make sure you finish those 5 questions, and then I'll see you guys on Thursday. Most likely on Thursday, what I'm going to do is I'm going to give you guys some sort of an assessment on arithmetic and geometry sequence, and just to see how you guys understand it. That will be the last grade for this marking period 3, so please try your absolute best. This is your last chance to make it up, plus any quizzes that you want to make up for. Please let me know. Thank you and have a good day.